chapter 8. إذا وقت نحكي عن chapter 9 اللي هي alcohols. alcohols موجود actually بالسنة الأولى وبالسنة الثانية في two parts أو three parts. رح نقول one part معناتها بناخده بالسنة الأولى وهو رح تشوفوه هلا بسميه أنا part 1، وبعدين رح ننتقل ل part 2 و part 3 اللي هن جزء من الكونتنت تبع مادة السنة الثانية. فإذا في أشياء بدنا نمر عليها سريعا مثل العادي النومنكليتشر وقصص سريعة وتنوصل للكيمستري of alcohol and reactivity of alcohols. First, let's define alcohols. I'm sure you all know what an alcohol mean. Alcohol في عنده hydroxyl group OH bonded to the carbon of an alkyl group. هيدا شغلة لازم تكون معروفة للكل. alcohol. وعادة نعمل classification للالكوهولز حسب the number of carbon directly attached to the carbon اللي عنده OH. For example, if the primary alcohol like this one has a carbon attached to OH معلق ب 1 carbon directly here, okay, or attached to primary carbon. The secondary alcohol بنسميه secondary alcohol where the carbon معلق بال OH معلق ب 2 alkyl group أو 2 carbons directly. هذا secondary alcohol. و tertiary alcohols هن النوع الثالث أكيد where the carbon مع OH connected to 3 carbons or 3 alkyl groups. Now it's important to know this classification because you see that different classes of alcohols will behave in different ways in some reactions. فإذا لازم نعرف نميز بين البرايمري بين السكندري وبين tertiary alcohol. When it comes to naming, as usual, I skip the naming, okay, because you should know some of the names, okay, it's not important وما عندنا طرف الوقت نحكي كتير naming، بدنا نركز على الأشياء الأهم, okay. So you can simply read these parts about naming, okay. Rules are the same as for alkenes or alkanes. The only difference here is that you start numbering from the side nearest the OH. OH هي the functional group of alcohols وهي اللي بتحدد the direction of numbering of the longest carbon chain مثل العادي. Okay. طبعا the name will end with an OH with an OL for alcohol. Well, you have many examples you can practice. You can see how we name these alcohols, cyclic or acyclic. وأنا I'll be ready to answer your question إذا عندكم مشكلة بالnaming, which I doubt. Okay, لأنه straightforward ما في شيء. فإذن all this to be skipped. في عندي بس هالبارت هيدا بدي أحكي عنه لأنه حدا سألني بالنوموكليتشر بالالكينز مرق معكم شيء اسمه سميناه ميثوكسي أو إيثوكسي I don't know, don't remember. فحرجيكم منين جاي هالإيثوكسي وميثوكسي. These are groups عندهم general formula RO, okay, R is an alkyl group, are called alkoxy groups and are always cited as substituent. فإذا methoxy هو لازم نسميه هيدا methyl oxy فبنختصره بنحوله لميثوكسي. هيدا اسمه ethyl oxy فاختصارا بنسميه ethoxy. Isopropyl هيدا جروب isopropyl group with an oxygen should be named isopropyl oxy وكمان بنسميه isopropoxy etc. The most two common alkoxy groups هن methoxy and ethoxy. هودي بنركز عليهم أكثر من غيرهم. أوكي باقيين مش ذات أهمية. هيدا ما يخص النومنكليتشر of alcohols. أوكي هيدا البارت الأهم بالنسبة لي. Few words about the structure of alcohols. Alcohols كتير قريبين للووتر من حيث الستراكشر. مثل ما بنعرف الووتر is bent أو عنده V shaped. Alcohols كمان are V shaped. إذا بتلاحظوا هيدا ال ROH, okay, it's like shown here the tetrahedron. The oxygen is sp3 hybridized, and most importantly that the bonds CO bond is polarized because the delta negative and delta positive, because oxygen is more electronegative than carbon, so it acquires negative charge, positive charge for the carbon. At the same time we have the oxygen and hydrogen, the bond is polarized. the delta positive on the hydrogen, delta negative on the oxygen. وبالتالي this molecule is عندها certain polarity, and this polarity, okay, will affect its reactivity. You will see that most reactions for alcohol will break the bonds. Either OH bond will be broken or the CO bond to be broken. Okay, structurally it's identical to water مع الانجل تقريبا 109 degrees حسب the alkyl group مثل ما شايفين حسب الالكيل جروب. اذا كبرنا الالكيل جروب اكيد رح تكبر الانجل اكثر شوي لحتى يبعدوا عن بعضهم الاتش مع الجروب الاكبر. هذا ما يخص الستراكشر هالقد بكفينا نعرف. بالنسبه للفيزيكال بروبرتي alcohols are known to have a high boiling point compared to other compound with the same molecular weight. For example, إذا أخذنا propane, which is have the same about the same molecular weight وزن كوزن يعني مثله مثل الالكين. لاحظوا هيدا gas boiled at -42 degrees بينما هيدا liquid alcohol 78 degrees Celsius. كمان إذا بتقارنوا تاني example بتلاحظوا الفرق بين الالكوهول وبين الالكين. شو السر ليش عندهم high boiling point؟ Because they form hydrogen bonding. The molecules of alcohol بين بعضهم بيعملوا hydrogen bonding. So in order to vaporize an alcohol تنسخنه ونبخره, we need to break first the bonds between the alcohol molecules, بعدين energy to be used later to vaporize the alcohol itself. وهون I'm showing you 4 different molecules of alcohols. I'm showing you the hydrogen bonding, okay, between 2 molecules in here. هيدا وهيدا عاملين hydrogen bonding, وبالتالي energy is required to break this bond in order to vaporize an alcohol. طبعا this is due to the different polarity of the oxygen and hydrogen in different molecules. okay, هون شايفين 2 molecules كمان, شايفين in total 4 molecules of alcohols وعاملين hydrogen bonding. This is responsible for the high boiling point of alcohols. Okay, and this is very important in terms of physical properties. They have high boiling point. Carboxylic acid too have high boiling point مثل ما رح نشوف later بعدين. Acidity of alcohols. This is a very important property of alcohols. Alcohols can behave as acid. An alcohol can behave as an acid and lose a proton. والدليل انه عنده ال pKa 15.9. It's about the same acidity as the water molecule. تقريبا نفس الاسيديتي. Being an acid means it can lose an H plus a proton. Okay. When it loses the proton طبعا بيطلع معي the conjugate base. The conjugate base of these alcohols when they behave like as an acid بيسموه the conjugate base بيسموه alkoxide ion. For example, if you start with ethanol, the ethanol رح يعطيني something called ethoxide. This is the conjugate base of an alcohol, conjugate base, since the alcohol is acting or behaving as an acid. طبعا نعرف الاسيد والconjugate base بما انه عندي weak acids, alcohols are weak acid, their conjugate base طبعا لاني بلس من كبه they are supposed to be strong base. Weak acid, its conjugate base is a strong base. Now, how can we generate these conjugate base? طبعا we need a strong base to remove such an H. If you consider, for example, the HO minus, which is known to be strong base, عادة بالجنرال chemistry بيعلموكم strong base هيدا. Or if you attempt to remove an H from an acidic alcohol, one it's behaving on an acid, بنحاول نشيلها. It's an acid-base reaction. The OH minus as a base accept an H from the alcohol, بتحول ل H2O. So we have this bond to be broken, تنكسر, وهاي البير of electrons بينتقل للأكسجين. اوكي, وبصير عندي CH3O minus بما انه عندي 3 lone pairs. At the same time the HO minus by gaining an H and acting as a base تتحول ل H2O. طبعا we cannot convert an alcohol to its alkoxide conjugate base by using a base such as HO- is not strong enough. To convert an alcohol to its conjugate base and to alkoxide, we need to use a stronger base. Stronger base such as KH or NH. As usual, let's remove the K plus from this compound. شو بيبقى معي? H minus, hydride ion. Let's remove the Na plus, which is useless. كمان بيبقى معي H minus. So فعليا, the H minus is a strong base that we're using to remove an H from an alcohol and to convert it to its alkoxide conjugate base. Strong conjugate base أكيد. لأنه عم ننطلق من acid that is weak acid, وبالتالي the conjugate base is strong base. We can use either KH or NH as a strong base to perform this acid-base reaction. Now remember, the alcohol is behaving as an acid here. Or we can use simply the metallic sodium or potassium. كمان بيعطونا نفس النتيجة. Okay? The alcohol treated with sodium or potassium. مش ضروري sodium hydride or potassium hydride. كمان راح يطلع معي the conjugate base which is strong enough, okay, to be used later. طبعا بيطلع معي hydrogen gas as a byproduct, and this is not important. Usually we only show the alkoxide conjugate base as a product. ما في داعي نكتب the other product as usual. هذا كان ما يخص the acidity as of alcohols, which is very important. بتمر معنا كتير خاصة بالماتيريال السنة الثانية. كمان مفترض بالسنة الأولى علموكم electron withdrawing group increase the acidity of an alcohol. Here I'm showing you a series of 4 alcohols, OH, with electron withdrawing group, electronegative atoms attached, FClBr. You notice that when the electronegativity of the atoms here, FClBr, decrease, okay, عمال تنزل acidity. Because F is most electronegative, it withdraws electrons from this OH and makes the H acidic أكتر. Cl less electronegative, Br less electronegative, وبالتالي the electronegativity of the element here affect the acidity. More electronegative element makes the alcohol more acidic. كمان the distance between this element and the OH is important. It's the same F, okay, makes this compound more acidic than this one because F in this first compound is closer to the OH. So its effect is felt more by the OH. هون صارت أبعد شوي وبالتالي ال OH بتحس فيها أقل. طبعا more acidic than the compound with no F, with no electronegative atom at all. فإذا هودي كانوا F electron withdrawing group that affect the acidity of the alcohol. هيدا كله من chapter 2 مفترض تكون شفتوه بالسنة الأولى. At the same time, alcohols actually are weak base. يعني هذا بذكرنا بالwater. Water can act or behave as an acid or as a base. سميناه amphoteric شيء. نفس الشيء for alcohols. Alcohols are weak base. They can behave as weak bases and they can gain a proton. يعني they can accept a proton. طيب by acting as a base يعني إذا بيكون عنده lone pair. This lone pair موجودة على الأكسجين of course. So this same alcohol اللي شفناه بالسلايد قبل عم يشتغل كأسيد ممكن يشتغل كبيس. How? It can accept a pair, an H plus from an acid. So if you treat with H3O plus, in this case the alcohol can behave as a base. يعني it accepts an H plus and H3O plus behave as an acid. It loses an H plus بتحول ل H2O. شو صار بالالكحول لما اخذنا H plus اخذنا له H plus؟ طبعا only one lone pair is left on the oxygen. Second lone pair استعملناه to connect to the oxygen, to the H, sorry. A positive charge developed on the oxygen and the relationship between this new form of the alcohol and the alcohol itself هو عبارة عن هذا conjugate acid of the alcohol. So this is the conjugate acid of the alcohol. وطبعا we create the conjugate acid by adding H plus to the alcohol. These compounds are strongly acidic. فيني نسميه sometimes protonated alcohol. يعني alcohol after being after we add H plus to it. These protonated alcohol are very strong acid, as you can tell by their pKa values. For example, this one, this conjugate acid of alcohol, هذا هو نفسه. It's the protonated methanol, هذا هو نفسه. The pKa is negative, minus 2.5, and we know what does this mean. This means that you have a strong acid, which means these species can lose an H plus very easily. The same for the conjugate acid of ethanol, which is another example of a strong acid. Having said that, I'm ready for the reactions of alcohols other than acidity and basicity. Now, ما حدا يفوت شوش علي. Reactions of alcohols. Now, in chapter 5 last year, حكيتوا عن alkyl halides وحكيتوا عن الnucleophilic substitution reaction, SN2 and S1 reaction. وكمان حكيتوا عن alkyl halide. حكيت لكم عن alkyl halide انه بيعملوا elimination reaction by different mechanism, E1 or E2. The same thing can be said about alcohols. Alcohols will undergo كمان nucleophilic substitution reactions, SN2 or SN1. Alcohols may undergo elimination reactions to form alkenes مثل ما راح نشوف. كمان the mechanism will be either E2 or E1. So let's see how alcohols react in a nucleophilic substitution reaction, which means, let me remind you, substitution means replacement. I replace one group with another. For example, if you attempt to react an alcohol, such as this one, with Br minus, hoping to replace the OH with the Br. Okay, يعني عم نعمل substitution reaction. Reaction will not work. You cannot make CH3Br from CH3OH. You cannot perform nucleophilic substitution reaction with an alcohol. The simple reason is that the OH, which is supposed to be the leaving group, is a strong base, and strong base are not good leaving groups. So an OH is a strongly basic leaving group, so it's not good leaving group. يعني the bond between carbon and oxygen is very strong, مش بسهولة بنكسرها وبنحط محلها Br. So because we have very poor leaving group, وخليني أذكركم, the best leaving groups are the weakest bases. تيكون good leaving group بده يكون weak base. فتبين الالكوهولز ما عندهم good leaving group, وبالتالي we don't expect them to undergo nucleophilic substitution. بس نحن قادرين نحتال عليهم ونحولهم ل good leaving group. If OH minus is not good leaving group, okay, what about converting the OH group, which is not good leaving group, into a weaker base? بس نحول OH to a weaker base بيطلع معي better leaving group. يعني leaving group ability إلها علاقة بالbasicity. كل ما كان weak base كل ما كان better leaving group. So when you succeed in converting the OH into a weaker base, بيكون بصير فينا نعمل nucleophilic substitution reaction. How can we perform that? It's very simple. By protonation of the alcohol that will change the leaving group from HO minus to H2O. كيف يعني? This same CH3OH, the alcohol methanol that you attempt to react it with a Br minus only, let's react the alcohol with HBr instead. Reacting with HBr, يعني reacting with an acid. So the first step of the reaction is an acid-base reaction. With the alcohol acting as a base, the HBr as an acid, بصير في transfer of proton from the HBr to the alcohol. So what we get, the alcohol is now protonated. صار عندي protonated alcohol. Now our leaving group بطلت OH, صارت H2O بس بتفل هيدي بتفل as H2O وبنعرف H2O is a weak base وبالتالي is good leaving group. So once you have changed the OH into H2O, we are ready for the next step where the Br minus behave as a nucleophile بيجي بيعمل اتاك على الكربون وبيشحط ال H2O بيشحط ال H2O بما انه صار عندي weakly basic leaving group a good leaving group و by simple heating we have the Br replacing the H2O which is gone as a leaving group is a good leaving group. So this is one way to convert the bad poor leaving group OH into a good leaving group H2O. It's by protonation. Now, so we have succeeded in making the alcohol undergo nucleophilic substitution reaction by protonation. This is not the only way. We will see other method for performing nucleophilic substitution reaction on alcohols besides changing the OH into H2O. Okay. Now, all kind of alcohols will undergo nucleophilic substitution. يعني the primary, secondary, and tertiary alcohols will react with HI, HBr, and HCl. فإذا هودي بيلعبوا دور acids. The protonate first the alcohol بعدين بيصير في عندي replacement with the Br or the I with Cl بيكون عملنا substitution. For example, a primary alcohol such as this one treated with HI. Okay, طبعا step 1 protonation of the alcohol. وتاني step تجي ال I minus بتقعد محل ال H2O بيطلع معي. Another example showing secondary alcohol this time is cyclohexanol. Secondary, this time with HBr, H protonate the OH, so acid base reaction. وبيتحول OH to good leaving group. ترجع ال Br بتقعد محل ال OH أو ال H2O بيطلع معي new product and alkyl halide. لاحظوا heat is required with the primary and secondary. خلينا ناخذ example of tertiary. With tertiary, هذا tertiary alcohol, you simply add HBr and no need for heat because the reaction is very fast. And we'll understand why in a minute when we explain the mechanism of these reactions. Here too, the OH will be first protonated, acid-base reaction, making this better leaving group. Then the Br minus will attack the molecule and we replace with Br. Overall, we are replacing the OH with Br. That's why we call it substitution. Now, are these three classes of alcohols behaving or undergoing the substitution reaction by the same mechanism? The answer is no. The mechanism will depend on the class of the alcohol. هتلاحظوا secondary and tertiary alcohols actually will undergo reaction by SN1 reaction. By SN1 mechanism يعني. اللي شفتوها السنة الماضية رح نرجع نعيدها. بينما the primary alcohols will undergo SN2 reaction. Let me show you the SN1 reaction for secondary and tertiary, how it occurs. Keep in mind that the first step in all the reaction is the protonation of the alcohol. إذا ما عملنا protonation, إذا ما تحولت ال OH ل H2O ما فيها نطيرها ونعمل substitution reaction. Okay, let's take this example where you have an OH alcohol tertiary هالمرة وعم نحاول نعمل substitution with HBr. يعني we're trying to replace the OH with Br. Step 1, protonation. An acid, HBr, reacting with the basic alcohol. Where is the most basic atom in the alcohol? It's the OH, the oxygen. It's the only basic atom actually. يعني عندها lone pair. So فيها تعمل شغل base. Protonation, we have an H2O now instead of OH. Okay, and the positive charge is located on the oxygen. And we have finished the protonation step. طبعا at the same time the Br is gone لأنه H ما فيها تتعلق بأكثر من bond. مجرد ما تعلقت بال OH ففلتت ال Br. At this stage you see that it's possible to lose the H2O as a good leaving group, it's a weak base, and forming a tertiary carbocation behind. هذا اللي بيصير بال SN1. Remember SN1 first you form the carbocation. إذا بتفل ال H2O بدون ما يتدخل ال Br minus وبالتالي you form a tertiary carbocation. So we break this bond. The two electrons اللي معلقين ال C بال O بياخدهم ال H2O بتحول ل pure neutral water وبيطلع عندي tertiary carbocation. خلصت ستيب الأولى اللي عملت لي carbocation tertiary it's very stable. وهلا اجى دور البي ار ماينس اللي فلتت معنا هون. بي ار ماينس in second step بيact as a nucleophile اوكي وبيعمل اتاك على ال C plus nucleophile attacking a C plus electrophile وبيعطيني the final product. So the carbocation react. This is what happened in the SN1 reaction. And this is possible because we are allowed to show a tertiary carbocation لأنه stable مسموح نكتبهم إنه بيتكونوا معناها إنه stable. The same is true for secondary carbocation. يعني لو انطلقنا من secondary alcohol كنا عملنا نفس steps كان طلع معي secondary carbocation كمان هذا هالشيء مسموح نعمله. So إذا بدي أرجع أختصر شو قلنا هون. أول step كان protonation of the alcohol by the acidic HBr. The weakly basic leaving group water is expelled لحاله بدون assistance من النيوكليوفايل forming a carbocation. In this case is tertiary stable. The carbocation react as an electrophile with a bromide ion to give the substitution product. This is true for tertiary and for secondary alcohol. طبعا this cannot be true for primary alcohols because we cannot allow the formation of a primary carbocation. Primary carbocation ما stable. وبالتالي إذا عملنا نفس البروسس هون بالبرايمري كاربوكاتاين توصل لهون كاربوكاتاين ما ستيبل ممنوع نكتبه. فشو الحل؟ ايه بدل SN1 we perform an SN2 mechanism. Let me show you the SN2 with a primary alcohol. This is not important. Here's just telling you that tertiary are more stable than more reactive than secondary alcohol. Also for secondary we need heat بينما for tertiary we not need heat. شو السبب يا ترى؟ السبب انه هيدي الرياكشن بتكون خلالها tertiary carbocation بينما هيدي الرياكشن تاني مع secondary بتكون خلالها secondary carbocation ومعروف tertiary is more stable than secondary. معروف انه the more stable the carbocation the faster it is formed. فإذا هذا تفسير ليش tertiary react faster than secondary والدليل مع secondary we need heat بينما مع tertiary we don't need any heat. طيب what happened with the primary alcohols? They cannot undergo SN1 definitely because we are not allowed to show a primary carbocation. Instead let's see what happened. Let's start with this primary alcohol. The first step is the same, is protonation. Alcohol behave as a base, accept an H from HBr, the Br departs. We have a protonation step. Okay, once you protonate this oxygen to make it a better leaving group, we have the leaving group H2O ready to depart. In SN1 كنا نسمح لل H2O تفل لحالها بدون مساعدة من البي ار ماينس. تكون عندي كربوكاتين بس بهالحالة هون مش مسموح نعمل هيك لأنه إذا سمحنا H2O تفل لحالها رح يطلع معي primary carbocation. Imagine positive charge on this carbon. وبالتالي هيدا ممنوع. Primary carbocation is highly unstable. إذا بنفس الوقت nucleophile إجا عمل backside attack عمل attack على الكربون from the backside يعني typical SN2 and at the same time H2O departs بفل بنكون تجنبنا so we avoid forming a primary carbocation لأنه before H2O departs بيكون BR عمل bonding مع الكربون وبالتالي بيكون حققنا the substitution reaction. يعني we have replaced the OH with the BR via an SN2 mechanism اللي هي involve backside attack by the nucleophile at the same time the leaving group departs. بس هذا اللي بصير خلال SN2 هذا اللي بصير خلال البرايمري مع البرايمري الكحول. إذا first protonation لاحظوا بالالكوهولز على طول أول protonation بعدين the nucleophile Br minus here hits the back side of the carbon and displays the leaving group اللي هو in this case is water. So هذا الفرق بين SN2 و SN1. First step in both is protonation. فهذا مهم جدا نتذكره. ملاحظة أخيرة when we are using primary alcohols with HCl as an acid, usually the reaction is not fast, it's very slow. Sometimes we need a catalyst اسمه ZnCl2, zinc chloride as catalyst, otherwise the reaction very slow. السبب بسيط انه اوكي راح يصير في عندي protonation acid base reaction. لما بيجي دور Cl minus is not good nucleophile, is not as good as Br minus or I minus, وبالتالي it's lazy nucleophile نعتبرها. و only when ZnCl2 is used بتصير عمليا تشتغل منيح كنيوكليوفايل وبتعطيني the final product. Okay, the nucleophilicity of the groups is I minus more nucleophilic than Br minus, which is in turn more nucleophilic Cl minus. So Cl minus is a poorer nucleophile than Br minus and I minus. So that's why اضطرينا نجيب له مساعدة من ZnCl2. Only with HCl we need ZnCl2. Okay. And finally, rearrangement is possible for SN1. Okay. So you have to keep in mind every time you have formation of carbocation, you have to check for possibility of rearrangement. And here is an example. If the starting alcohol, the secondary starting alcohol is treated with HBr, step 1, protonation. After protonation, we expect the leaving group to depart, لأنه عم نحكي SN1, without any help or assistance from the nucleophilic Br minus. فلت H2O, we create a carbon positive behind, left behind. It's a secondary carbocation. Now we expect Br minus to react in step 2 with this secondary carbocation. بيعمل bond مع الكربون. هذا راح يكون only the minor product. Why? Because this carbocation is secondary. في عندها إمكانية تتحول ل tertiary by hydride shift. H move 1 to hydride shift change the secondary carbocation to a tertiary carbocation كما شايفين هون, which is more stable أكيد. And the Br minus بيكون كمان جاهز يعمل reaction مع هاي tertiary carbocation as a nucleophilic electrophilic reaction. و the Br minus end up on this carbon وبيطلع معي هيدا هو الميجر product. فإذا every time you have SN1 you have carbocation, make sure you examine for possibility of rearrangement. Okay.